Okay, it is 3:30 by my watch. I think let us get started. Good afternoon, everyone. I would welcome everybody today in a weekly webinar series organized by Center for Advanced Studies, Lucknow. I would like to very warmly welcome speaker of the day, Professor V. Ganeshan, who is a retired professor from IIT Madras, from the Department of Mechanical Engineering. I shall not waste any more time in getting this started. I would request Chitra ma'am to kindly introduce the speaker uh, and post that we will begin. Ma'am, you are mute. Kindly unmute and then speak.
Am I audible now?
Yes.
Yeah. Good afternoon to everyone. A very warm welcome to Dr. Professor V. Ganeshan. On behalf of the entire CAS team and the AKTU team, I welcome Professor V. Ganeshan to our weekly webinar series at CAS. He was born in Nagarkoil, Tamil Nadu in 1945 and had his schooling in the same town. He graduated in mechanical engineering in 1967 from Government College of Technology, Coimbatore. Thereafter, he was selected as Technical Teacher Training Program of the Government of India and posted to Indian Institute of Technology, Madras, where he completed his MTech degree in 1970 with first rank in IC engines and gas turbines. He pursued his doctoral program in the same institution and obtained his PhD. Starting as technical assistant in 1970, he became lecturer in 1973, assistant professor in 1979, associate professor in 1984, and professor in 1987. Dr. Ganeshan had a deep involvement in IC engines research and was awarded the prestigious Commonwealth Scholarship in 1974 for postdoctoral research at Imperial College of Science and Technology, London. His work on the numerical modeling for fluid flow heat transfer combustion process relating to engines received considerable acclaim. Dr. Ganeshan was invited by the Japanese Society for Promotion of Science to pursue further research in Kyoto University in 1986-87. Returning to IIT Madras, he immersed himself in conducting research in chosen area of specialization, guiding several PhD projects and MTech students, and teaching at undergraduate and postgraduate level. Over 100 BTech students, 60 MTech students, 17 MS projects, 40 doctorates stand testimony for his productivity in IC engine and gas turbine research. Dr. Ganeshan has so far published more than 403 papers in national and international journals and conferences. He has attended many international conferences throughout the world and has chaired many technical sessions. He has organized many national and international conferences and workshops. Awards and laurels won by Professor Ganeshan run into volumes. So far, he has received 53 awards and he is a fellow of Society of Automotive Engineers, USA, International Academy of Engineering, Institution of Engineers, National Environmental Science Academy. Dr. Ganeshan has also authored 3 popular books on IC engine and engine simulation, and a book on gas turbines, and another on heat transfer, apart from editing several proceedings. He is a member of many professional societies, including SAE, and is an active consultant to many reputed automotive industries and R&D organizations. Professor Ganeshan, we welcome you and invite you to please give your talk and illuminate us on with your research and findings and your experience which you had in this long journey.
Thank you for your introduction. Today, I propose to talk on the subject, namely what are the recent advances that have taken place in the automotive sector. Actually, I worked in the field of automobile engineering or internal combustion engine for the last 48 years. And today's talk is based on what we were and what we are and what we will be in the future as far as automotive engines are concerned. And today's talk is what are the recent advances that have taken place in automotive industries. And I will go step by step projecting my PowerPoints, including a little bit of wit and wisdom and stories to make the presentation live. And I welcome all the participants. And I now see that there are about 21 participants listening to the lecture. Now I will be sharing the screen and let us see how the, and if you have any question to be asked, we will do it in the chat mode. You write the question to me. I will answer that. At the same time, I would request all of you to mute their audio so that there will not be any disturbance in that. Video and audio also, so that you will be able to hear me. Dr. Chitra, are you able to hear me? Hello?
Sir, I'm able to hear you. Yes, sir, I'm able to hear you.
Yeah, the voice is clear.
Yes, sir, your voice is clear.
Now I will share the screen.
Yes, sir.
Then project on the slides.
Yes, sir.
For sharing the screen. Are you all of you able to see the screen?
No, not so far. We are not able to see the presentation.
You are not seeing?
No, not the presentation.
No, okay. Just let me see.
Yes, it is coming.
Is coming?
Yes.
But is something hiding on the right side. This one and Dr. Chitra's figures are there. How to?
Yes, your presentation has come, and it has.
Yeah,
Once you put it on.
You are able to see the presentation. You are
Yes.
able to see the slide.
Yes.
Yes.
Once you put it on the full screen mode, then it will come on the full screen. Yes, now it is on full screen.
Yeah, can you let me see that all of you are able to see that?
Yes, sir.
Yes. Now let me start the subject matter. The subject matter is the recent advances in automotive engines. Now the question is why we are looking for the more and more advancement in automotive engine is because of the fact that we automobile engineers are blamed to be responsible for the polluting the atmosphere, responsible for polluting the atmosphere. And therefore, it becomes the bounden duty on us to reduce these pollutions. And as you could see, today, it is not possible to live with an automobile. Everything we are depending on automobile. And year by year, the automobiles are increasing on the road, and we are in the crossroad as of today. That what exactly we are going to do if the same condition is prevailing and the environmental temperature is rising, that is global warming is taking place. And if the global warming is going out of control, then what we are going to do? And therefore, we are looking for the solutions. And I will be talking from the beginning how these automotive engines were invented, what we are, and what we are going to do for the future. Now, if you see this slide, I would say this palace, the palace Versailles Palace, built in between 1967 and 1688, ruled by King Louis XIV at the time, is responsible for the good or bad of the automobile today. Now, if you see this palace, which is in Paris, has got about 640 acres of greenery in those years, in 1688, etc. And the king ordered the water boy that it should be watered daily. The greenery should be watered daily. And if you see that at that time in 1600, there were no electricity. And therefore, the water boy, his name was Eugene, he thought that if he could have as a mechanical means to lift the water from the well and pour it, it would have been wonderful. And this is the person, and his elegant idea came, as you see in this figure, this came, and this is the engine he invented at that time. This engine is called the gunpowder engine. This is the conceptual drawing for the internal combustion engine, which is originated from Eugene in 1673. Now, how exactly it works? Now, if you see that you have A, B, C, D, etc. marked, and here is the place where he put the gunpowder, and this was the cylinder. This was the cylinder, and there was a piston. Eugene thought that if you could explode the gunpowder, the force will raise the piston up, and the bucket will come down, and it will fetch water from the well. And because he has provided the exhaust there, the exhaust gases will go out, there will be a vacuum, and the piston will come down. So by means of this reciprocating action of the piston in the cylinder, he could fetch water from the well and pour it to that. In 1600, it was considered as a very elegant idea, and he utilized this principle to water this one. Then what happened is, because of this invention, he could get into the mechanical means for getting some work done. But before the invention of the gunpowder, how did the man use, what he used for the mobility was the question. And if you see that, it was through Shank's pony. Man utilized Shank's pony for the mobility. But most of you may not be aware what is Shank's pony. That is, by the by, what is Shank's pony? I will show the next slide for a small duration. And don't imagine too many things on that. And I will quickly pass on to that. And this is what is Shank's pony, and which is nothing but the human feet. The human feet was used for the mobility. Then people started using SUVs. SUV is nothing but the sport utility vehicle that we call it as the automobile or the car today. And if you see, very interesting thing in the SUV, and this is our original SUV that the man was using. And if you see this SUV and the present day car, you go and verify it in your automobile, all the system what this original SUV had we are having it in our automobiles run by the engines. Now, if you see, you have all natural fuel systems and eco-friendly exhaust system, then global positioning system, then onboard voice command system, and 4x4 off-road drivetrain, and independent rear suspension system, and a memory feature and braking, and a strap and bit of steering, and luxury leather seating. And if you go and verify your automobile, all these systems are today available on your car. So this is our original SUV, which man utilized for the mobility, and we got rid of the horses and got into the engines today. So, but what is the problem of this SUV? Why we could not continue with SUV? This SUV is mainly because it is pollution. What type of pollution we faced? The pollution that we faced is called the solid and liquid pollution. And from the literature, if you see, horses were dropping about 1,500 to 2,000 tons of semi-solid dropping every day on the street. And further, they were pouring about 200,000 liters of urine every day on the road. Very alarming situation it was, and people could not live with these horses because the number of horses on this were extremely large. So we wanted to get rid of these horses. That means we faced the pollution some 100, 200 years back, and today also we are blaming the automobile engineer for the same pollution. Then what happened? Because man wanted to get rid of these horses, they wanted some mechanical means for the transport, and then came the most interesting thing, or the invention of the two great pioneers. I would call them so great because today the entire world depended on automobiles. And these are all the two pioneers whose names were August Otto and Rudolf Diesel. And Nicholas August Otto, he invented the spark ignition engine, which we call it the petrol engine. And Rudolf Diesel, he invented the diesel engines. So if you see today, the cars or the automobiles that we are using these two, basically these two engines, and probably the great invention which has helped us for our mobility, but at the same time, we are being blamed that this is mainly responsible for the pollution. So engines used in these automobiles as on today are using two types of engines. One we call it as the spark ignition engine, and the other one we call it as the compression ignition engine. And if you see the working principle of these two engines, and these are working on a 4-stroke 5-event principle. Whether it is a petrol engine or it is a diesel engine, they work on the principle of 4 strokes and 5 events. These 4 strokes are suction, compression, expansion, and the exhaust. In these 4 strokes, there are 5 events that is taking place. The first event is the intake of air fuel mixture, and then compressing of the air fuel mixture. Then comes the compression, and then expansion and their exhaust. So there are two types of engines which uses both the same 4-stroke and 5 events, namely suction, compression, combustion, expansion, and exhaust. And if you could closely look at it, both of them are almost working on the same principle, whether it is a spark ignition engine or whether it is a compression ignition engine, the working principle is the same. And many students used to ask me, saying that, sir, how to memorize that which is spark ignition engine, which is compression ignition engine. So what is this difference between the spark ignition engine and the compression ignition engine? They used to ask me, but I used to tell them very jovially. So the difference between the spark ignition engine and the compression ignition engine is the difference between the love marriage and the arranged marriage. So the spark ignition engine is the love married engine, and the compression ignition engine is an arranged marriage engine. Now, what exactly happening in this engine is what will happen to your life and all of our life. For example, in the love marriage, what is taking place? The hero and heroine meet at some place that I call it the carburetor. In the carburetor, the fuel and air comes into contact to each other. So I would put air as my hero and the fuel as my heroine. And the air and fuel meet at the carburetor, that is the hero and heroine meeting at the carburetor. They are sucked into the system during the suction stroke. And many people are watching, they are put under pressure, compression. At the end of the compression, they decided to marry. The marriage is taking place, that is the spark. The marriage is taking place, that is the spark is the marriage. And after the marriage, what you will have children, CO2, H2O, O2, N2, NOx, etc., etc. And if there is a perfect understanding between the spouses, you will have only two children, CO2 and H2O. So in the case of these two engines, if a perfect combustion can take place, then the resultant products will be only carbon dioxide and water vapor. But unfortunately, the perfect understanding is not there. The time is not sufficient for the combustion. And therefore, what happens is we are producing carbon monoxide, unburned hydrocarbon, soot, NOx, and so many things. That is a problem. That is, as we do not have an understanding in our country, because in 1947, we were 47 crores of people. And today we say that there are 130 crores of people in this country. And therefore, what is important is whatever happening is happening inside the engine. And therefore, if we have to see that the pollution is the main problem, if we are seeing that pollution is the main problem, the question is how to reduce this pollution. I will come to that. And what are all the various advancements that we are taking that are taking place in these two engines to reduce the pollution is the talk of today. And therefore, if you see this spark ignition engine, the fuel and air mixture come into contact and they get into the cylinder, getting compressed, ignited by a spark, and exhausted and expanded, and then exhausted into the atmosphere. So the hero-heroine meeting is taking place outside the system, and therefore I call it that a love marriage. They meet each other outside the system. And here, if you come to the diesel engine, what is happening is that air is sucked. If you know the principle of working of a diesel engine, the air is sucked, that is, hero is coming into the system, getting compressed, that is, for example, you take a final year student of engineering college, you complete this one, go to your house after the examination, and then your parents are putting you pressure on that. Anyway, you are getting the degree, you have to get married, and they take you to your bride's house, and the bride is shown for a few seconds. That is, air is sucked, air is compressed, and the fuel is injected in a very short duration. And this fellow has to say yes or no at that time. And if he says yes, the marriage takes place, otherwise it's a vicious cycle. And therefore, after the marriage, again you have children, CO2, H2O, O2, SO2, etc. But the products of combustion that is coming out of a spark ignition engine is different, slightly different from the products that are coming out into the compression ignition engine. Now the main problem is these two engines is that we have not understood the process of combustion. Whether an automobile engineer or a mechanical engineer or a combustion engineer, the main problem that we face is that we have not understood the main process of combustion. Now here I will ask a question to the audience and they can send me the reply in the chat at the end. And we will, depending upon how many have answered well, we will discuss it further. For example, why I am saying that we have not understood the process of combustion is because of the fact. Now let me ask the question. Now assume that there are two bottles, and in the two bottles, in bottle you have petrol, and in another bottle you have diesel. Both of them, there are no cap on that. Both of them are open. Or let us take two beakers. One beaker is full of petrol and another beaker is full of diesel. Now, if you bring a lighted matchstick, at the top of the petrol or diesel exactly at the same time, my question is, which will catch fire first? Now you have to listen to that. Which will catch fire first? Please send the answer at the end. We will discuss about it. And most of us would not have understood this problem. We will come to that at the end of this session. And therefore, if we have not understood the process of combustion, then how are we going to reduce it? Then the question comes, why we have not understood the process of combustion? It is because of the time factor. Now, what you have to understand in these engines is that each cycle consisting of suction, compression, combustion, expansion, and the exhaust has to be completed not in terms of seconds, in terms of milliseconds. Suppose an engine is working with a speed of about 3000 RPM, then the time that is available for all the 5 processes to take place is less than 30 milliseconds. And in that 30 milliseconds, you have 3 milliseconds only that is available for the combustion to take place. And the main problem is that we do not have the concept of what is a millisecond is. Probably you may be able to perceive in your brain or in your mind what is 1 second. You see the clock, as the second hand moves, we are able to perceive it. But 1,000th of that, how are we going to perceive that 1,000th of a second? And therefore, we are now trying to find out for a problem of a solution about which we do not have the concept. The same thing we are in today regarding Corona also, because we do not know what it is, and we are trying to face it and trying to live with that, and therefore we are finding it very difficult because we do not have the concept of what exactly is it. As we are facing Corona today, people faced the problem of combustion in those years. But over the period of time, we could conquer on that, and today we were able to understand the process of combustion, and that is why these advancements came into picture. Namely, the advancement, I will come to that in a second or so. And therefore, friends, what we have to understand is that people, even though we are blamed that automobiles are polluting it, we are trying to reduce our pollution to the best of our ability possible. The main problem that we face is that when we, as an engineer, when we try to reduce this pollution, as a researcher, when I reduce the pollution, take the pollution of carbon monoxide or take the pollution of nitric oxide, when we are trying to reduce it by 50% by advancement, the total population of the vehicle increases by 400%. And therefore pollution is increasing. Not that we are not doing any research into that. And therefore, always we are blamed. And therefore, what we have to do, what I am trying to impress upon you is that you understand what exactly is the problem and don't put the blame on that. So look at it at the proper perspective, and you will get the answer. If you say automobile is a boom, is a bone or automobile is a vein. So depending upon how you look at it, you can call automobile as a bone or a vein. But today, we are not able to live without automobile today, and therefore, I would call this as a bone and not as a vein. And lot of research that are going on in this area, we are trying to understand it, and therefore, many advancements have come in these two power engine. We will go further on this. And if you see, this was the first automobile in 1894 that was built. When August Otto and Rudolf Diesel built their engine, people started using these engines for the mobility. And it was the first automobile that was built. Some problems were there, and further, it was improved upon by Fisher. And the first horseless carriage in 1895 came on the American roads. Before 1895, using horses, and horses were polluting the atmosphere. And after the invention of petrol and the diesel engine in 1895, we could get the first automobile on the road. This is what it looked like in 1895. And then a lot of advancement has taken place. But when the first automobile was seen on the American road, the US Congress, like our parliament, the US Congress in 1895, they gave this statement. They said that this discovery begins a new era in the history of civilization. And it said also, never in this history the society been confronted with a power so full of potential danger and at the same time so full of promise for the future of the man and peace of the world. And they said automobile is a wonderful invention, and one day it will become a great problem for the society. And today we are in the same road today. As I said at the beginning, that the horses were making pollution, dropping about 2,000, 2,500 tons of semi-solid droppings on the road. It was polluting the atmosphere. Today, if you see, if you take the Chennai city, we are having more than 1.5 million vehicles on the road every day, and we are polluting the atmosphere with the products of combustion more than 2,000 tons every day. Chennai city alone. Chennai city alone, 2,000 tons of the products of combustion is there. And also, these exhaust gases that are coming out of these engines is about 400 degrees centigrade. And that is increasing the temperature of the atmosphere. And therefore, as they said, that in one day this is going to be a problem, we are facing the problem today regarding the pollution. So this statement became true today. It is believed that automobile is the main contributory factor toward the mankind for the environmental pollution. This puts the entire ecosystem under great strain. Pollution is putting an ecosystem into the great strain, and therefore it becomes our duty that to reduce these pollutions. And if you go back into the history, in 1940, only about 10 families owned a car, and they increased the World War II, etc., etc. By 1970, the majority of the family are owning a car. Right? Today, probably one family owns 2 cars. So that is the rate at which the automobiles are being used there. And there is a possibility that it will be a problem for the atmospheric pollution. What people have started blaming automobile engineers for this pollution, but what I believe is not that is the only source of pollution. There are so many other pollutions are coming, and therefore the way that you look at the problem, you will get the result. And therefore, I would say the automobile is one of the sources of pollution, and therefore you cannot blame mechanical automobile or combustion engineers for this. And therefore, I would put it as to all my students and participants that look at in a positive way. Automobile is a boom, definitely, but some people call it as a bane because it is polluting the atmosphere. The boom or bane is depending upon how you look at things. For example, the same problem, you can look at it on a positive side as well as a negative side also. I will give a story on this. One of the shoe company sent one of his representative to a remote island where there were Adivasis only living, and they wanted to know whether they could start a shoe company there. This fellow went there, studied all these places, and found that nobody know what exactly a shoe or a chapel is. And therefore, he gave a report to his company. There is no point in starting any shoe company here because of the fact that there is nobody wearing the shoe, there is no market. And another company sent another representative to the same island. He saw the same situation, and he wrote a report to ICAM. This is the best place to start a shoe company, because he said that there is no competition and people are not wearing the shoe, and if we can educate them that how to use the shoe and what are all the advantage of that, we have a tremendous market in this island. And therefore the same problem, you will be able to see it as a positive side and the negative side. And therefore, friends, you look to things on the positive side. Automobile is definitely a boon, and we are trying our best to reduce the pollution to the best of our abilities as possible, and definitely automobile is a boon. And the situation, of course, is alarming, no doubt about it. For example, if you see this picture, in 1967, this is the picture in 1967. Why in 1967? At the time I joined the IIT Madras in 1967, and this is one of the famous road, we call it that the Mount Road. And 1967, you see only one car on the road and all the bullock cars are going on that one. And 2007, I went to the Mount Road and took the picture on that. See the difference in 40 years, how our automobile has increased on the road. And therefore, this is mainly responsible for the pollution. And therefore, we have to reduce the pollution. We are in that. And therefore, what we are trying to do is we are making a lot of advancement in these automotive engines. There are two engines, petrol and the diesel, which we will call it that the conventional engines. And these conventional engines has to be modified to reduce the pollution and the improvement the performance. But what is the problem? We are talking. Why we are not able to do? It is because of the fact, whatever we have said, the compression, expansion, etc., in my opinion, is only a guesswork. We do not know what exactly is happening. And like what we treat the corona today is what we are treating the combustion process into that, all guesswork. But fortunately, we have advanced in our theoretical studies, and the CFD studies have made things much easier, and thereby we could improve and make advancement in these engines. For example, this is, as I told, as was told, that there are about 15 students worked with me for their PhD to improve the automotive engines in that using computational fluid dynamics. So this is how an engine is working, depicted by the computer, which we will be able to do it according to our equation that is formed, how that inlet valve is going to open, close, etc. Everything that is inlet valve opening, compression is taking place. Now that expansion is taking place, just also we will be able to see that. And therefore, if you see, and by means of our computational fluid dynamics techniques, we are able to visualize. This is a theoretical visualization, not a practical visualization. It's a theoretical visualization. How exactly the air fuel mixture flows into the combustion chamber. Where exactly in an engine a problem is lying, and how to improve upon that is what we are now trying to do. We are able to see within our this one that as the things are going, how the air movement is taking place, how it is going out, how is it coming in, etc. We are able to perceive. Our computational fluid dynamics have increased or improved our understanding about these processes. So based on that, we could do a lot of improvement on that. And the main problem is that the performance of the normal engines, the conventional engine is almost saturating, and therefore we are going for the recent developments into that. So the recent developments on these are, one, we call it as the CRDA engine. Second one is the dual fuel engine. The third advancement is the free piston engine. The fourth advancement is the gasoline direct injection engine. Fifth is HCA engine. Sixth is the lean burn engine. Seventh is the Stirling engine, stratified gas engine, PCR engine, and Wankel engine. So there are 10 advancements has taken place in the engine side, but I will not have time to talk about all the 10 engines, because each one I will be able to talk for 1 hour. Then you will miss our dinner also if you are seeking into that. And therefore, I am thinking of doing only the 4 engines, namely CRDA engine, and then we will see GDA engine, then SCA engine, and we will go for the stratified charge engines and the Wankel engines. That is, I am going to take 5 of them to discuss what exactly is that. What is the advancement that is taking place in the automotive sector? First, we will go step by step. First, we will say the CRDA engine. That is common rail direct injection engine. Now, what exactly is the problem with an engine, in a diesel engine, is that the fuel that is injected into the cylinder is injected in the conventional engine with a pressure of about 300 bars. This 300 bar is not sufficient to atomize the fuel, because diesel fuel is little heavy, and therefore we require a higher pressure for atomizing it. And then came the technology called the common rail direct injection engine system. Diesel particles are heavier, and it causes, because of the heavy particles, it causes more pollution, lower fuel efficiency, etc. And therefore, we should inject fuel at much higher pressure. We should inject at a much higher pressure. And what is the pressure that we should use? Many people have tried from 300 bars to 600, 600 to 900. Today we are trying injecting the fuel with about 1,500 bars. And if you see the principle that is involved in that, there is a common rail. This is the common rail onto that. And the fuel is pressurized and put it into this common rail, and which could be sent into the various cylinders at the appropriate moment. And a new injector have been developed for that, operated by the solenoid, and be able to distribute annihilate the fuel like this and distribute it over like this. And therefore, what is happening is we are able to send the fuel in a finely atomized form. We are able to send fuel in a finely atomized form. That will help us to make the fuel evaporate faster. And once you make the fuel evaporate faster, the combustion will be better. So it will help the fuel to combine with air, and we will be able to do it much better in our combustion process. So this is the system that has been developed, and that is possible because of the fact the electronics is coming into the picture. Now, if you see engines today, the 30% of it electronics and 70% of them are mechanical. But probably in the future engines, 70% will be electronics and 30% only will be mechanical into that. And we are using this type of engines, this engine, to inject the fuel in a much atomized form, and the electronics, electronic controlling unit, fuel pump, all those things are operated by electronics is coming into our rescue, and we are able to inject the fuel in a much atomized form. Better combustion is taking place, and thereby pollution is reduced. So the latest advance is that CRDA engine in the case of a conventional diesel engine. Now, if you could see some 30, 40 years back, the normal conventional diesel engine and the conventional petrol engine, the petrol engine were high-speed engines. Because petrol can evaporate much faster than the diesel, they will be able to be operated at a much higher speed than the diesel engines. And therefore, we today, if you see, the diesel engine is also competing with the petrol engine in the speed. Originally, the diesel engines could be run only with 3000 RPM. Today, we are able to operate these engines about 6000 to 7000 RPM. Whereas, by using GDA technology, we are able to operate the petrol engine up to 10,000 RPM. And therefore, what was yesterday's petrol engine speed, today's diesel engine speed has come. And therefore, this technology has greatly improved. This advancement has greatly improved the speed of the engine as well as reduced the combustion of this one. And the injector and the spray pattern, we have designed the injectors to suit the common rail direct injection system. This we call it the CRDA injector. And how is it able to, like a mist, it is able to distribute the fuel into the, one is a fan shape, another is a cone shape. A lot of research went on to that, and we are using this CRD engine, that the latest advancement that has taken place in the case of a diesel engine. In a better view, how this fuel is injected, getting accumulated, etc., I have enlarged the figure and showing it to you. So this is what is the advancement in the diesel technology, which we call it as the common rail direct injection engine, CRDA engine. The advantages, disadvantages are many. That is available in my book. I will not be taking class, I will be giving lectures, and therefore we will not go into the advantages, disadvantages, etc. And then people thought, if we can do a better with the diesel engine with the common rail direct injection system, why not we try to inject petrol in our petrol engine? The gasoline direct injection system, we are also using the same technology, and over the period we are changing from the carburetor to the GDA engine, carburetor to gasoline direct injection. Until 1995, carburetor was the main source. With the improvement in automobile and the development, the carburetor got more and more complicated, because every year the atmospheric norms are becoming stringent and stringent, and we find that the carburetor is not able to meet the stringent requirement of the pollution, and therefore we have to go and find out a new. And this is very similar to CRDA and diesel engine. We are using the gasoline direct injection system to inject the fuel, petrol, into the combustion chamber. Now, if you see the evaluation history of carburetor until say 1995, the carburetor was there. Then we tried the injecting the fuel on near the throttle. Then we started doing it from 2000, okay, to about 1995 onwards. The gasoline direct injection system has come into the picture. What is the reason that we could not no more use the carburetor, no more use the carburetor, is because of the problem in the performance and the problem in the pollution. And you see that if you have a multi-cylinder engine, you find that there are a lot of accumulation of the fuel, and therefore this cylinder was getting the air fuel ratio which is rich, this was correct, and this was lean. And therefore in a multi-cylinder engine, there were lean, correct, and therefore there was a mis behavior of air fuel ratio in the various cylinders. And in order to reduce the this problem of non-uniformity of air fuel ratio in the various cylinders, the GDI engine came into the picture. And initially, the low pressure direct injection system we thought, and low pressure intake manifold system, and low pressure semi-direct also. So the gasoline injection for four-stroke engines evolved over the period of time, and that is how we are coming into that. And therefore, gasoline direct injection system is definitely a boon for us, by which we could increase the speed of the engine from 6,000 to even 11,000 RPM into that. So the picture shows that by proper air movement into the cylinder, you will be able to have an air fuel mixture near the spark plug, air fuel mixture which is chemically correct, and you inject the fuel and make the air movement in such a way that you get an appropriate air fuel mixture for the ignition, and you will do better into that. And therefore we have to design, variable design of the piston design has to take place, and there we have a spray gated, wall gated, and swirl combustion, tumble combustion, etc. I don't know how many of you know on that, so I will not go very detailed into that, because if you do not know, it may be little boring. So the spray gated, what is it happening is, in this development, now the spray will gate itself. This is the spray of the injector that will gate itself near the spark plug, where you have a fuel air mixture of 14:1 up to 15:1, by which the ignition starts, then the combustion will proceed much faster. By means of the direct injection of the air, the fuel, namely the petrol, into the cylinder, petrol being highly evaporative, it should quickly evaporate, and that in terms of microseconds, and form a mixture, and you will be able to do better. This is a spray gated, this one, and another one is the wall gated, this one. The combustion chamber is designed, modified in such a way, and the piston top is also changed in such a way that the fuel that is air that is coming into that make a thing, and carries away the fuel into that near the spark plug. All these things are made possible because of the fact that we are able to understand is by means of computational fluid dynamics. CFD is a very important tool in understanding the process of the flow inside the system, and thereby, by means of this, we are able to create an air movement like this, where near the spark plug, we will be able to carry an air fuel ratio, that therefore we call it the wall gated. This is gated by the wall and coming into that. And there is two, one is called the swirl, another is called the tumble. I will not go into those details, what is swirl and what is tumble is. To put it in a simpler way, swirl is the rotation about the vertical axis, and tumble is the rotation about the horizontal axis. I will leave it at that. And therefore, this engine has taken place. There are two important development has taken place in the diesel engine as well as the petrol engine. In the diesel engine, advancement is we call it as CRDA engine, and in the petrol engine development, we call it the GDI engine. Then people thought, why we cannot combine these two? That is, take the advantages of the diesel engine as well as they take the advantage of the petrol engine, combine these two things, whether we will be able to have a new type of engine, which we call it as the HCCA engine. What is this HCCA? Homogeneously charged compression ignition engine. Homogeneously charged is the spark ignition engine, and compression ignition takes place in the diesel engine, and therefore putting together we call it as SCCA engine into the picture. So SA engine, what is the reason? The SA engines have a very low NOx and particulate matter emissions. CA engine has a higher efficiency. So we wanted to have the cake and eat it too. And therefore we wanted to have both the advantages of the both the engine. And then the concept came, which we call it as the homogeneously charged compression ignition, is a positive alternation for the improvement of the efficiency and the lowering the NOx particulate matter into that. Because what happens in the SCCA engine, there is no spark plug that is involved. It is homogeneously compressed, and the compression pressure itself is sufficient to ignite it, and therefore the flame propagation will be correct and fast. And therefore this involve the principles of both the engines, namely the spark ignition engine and the compression ignition engine. It takes advantage of both the technology and comes into picture of the homogeneously charged engine. So gasoline engine, how the combustion is taking place. In the spark plug, it comes and the flame front started traveling, and how the combustion is progressing. In the case of a diesel engine, the spray is taking place, combustion is taking place at the various places, and thereby this. So these advantages, both combustion as well as the auto ignition taking place at many sources, the homogeneously charged compression ignition engine has both the advantage of the spark ignition engine as well as the compression ignition engine. So ultra low emission is coming to the picture in the case of SCCA engine. Then people thought SCCA engine, they're using the concept of the SCCA engine. Initially, we had an engine called the stratified charge engine. Now, all of you should understand and appreciate that the best air-fuel ratio for combustion is 14:1. Around between 14:1 to 15:1, if you are able to send the mission and ignite it, you will get the best result that is possible. And we are trying various possibilities and various methods for this, and that is how the advancements have come place. And what is the principle of charge stratification? Charge stratification means we would like to operate the engine at a very low air-fuel ratio. That is, at the time of ignition near the spark plug, we will have about 14:1 or 15:1 air-fuel ratio, and all the other places more than that. And this technology, if you see, that injector is split in such a way that near the spark plug you will have an air-fuel ratio, and the main chamber you will have a different air-fuel ratio, and that different concept have come into picture, and different way people have started working it, and each one got their PhD by working on that. So different concepts came, and if we have to explain each one of that, that will be too much for you to understand. So what is important to understand at this point is that the charge stratification, which is very exactly not the same, very similar to homogeneously charged compression ignition engine, is that we will have an air-fuel ratio different at a different places into that. So a lot of things came into the picture. And then I would also like to touch upon the other engine, which we call it as the Wankel engine. The Wankel engine is the one. The lean burn engine charge stratification are very similar into that. And we wanted to, the 1950, Felix Wankel invented this engine, which we call it as the Wankel engine. It has, but I would put it that this was the invention ahead of the time, because 1950, when it was invented, the material technology has not improved to that extent, and the whole thing was overheating. And I would rate this Wankel engine is a rotary engine. The Wankel engine is a rotary engine, and therefore this is the best for that, for the automotive purpose. but a lot of research still is going on, but it found is natural death into that. But this one engine is equivalent to 3 cylinders into that. That is what being used. There were a lot of problems and that, and therefore the Felix Frankel could not succeed into that. Overheating of the rotor, a lot of things took place, and therefore I will leave it at that. And this is engine as Japanese, and we are also trying to improve upon them on this one. And therefore, what I am trying to impress upon you is that a lot of developments are taking place in the area of automotive engines, where a lot of research is going on in this computational fluid dynamics, coming in a long way for making this engine to work better and better. So the Wankel engine, again, suction compression, all those things are taking place into that. Now, what is happening? What is happening is that now we are finding a definite change into the market. Original conventional petrol and diesel engine which we are using it, now getting replaced by the advancement that is taking place by CRDA engine as well as the GDA engines. But the success depends upon, okay, when we are doing it, of course, it involves a cost also, and all depends upon how we like it, how the OEMs are trying to do on that. So the popularity of the modern trends will continue depending upon your consumer. So they have to find the right price and the right demand, etc. So but the problem will be the automotive industries, because most of them are going to be operated by electronics. There is nothing like repair. If something goes wrong, you take the printed board out, throw it, and put the new board into that. And therefore, the automotive service sector has to change their into this. So just like computers, cell phones, and the internet, which were once new technologies, recent trends also will be integrated in our daily lives in the near future. Some independent repairers may feel this trend as a dark cloud over the industries. Others will see it as a green light. As I told you, already every problem has a solution except Corona. So we are facing on that one, and all the problems has a solution. But we have to find the right solution into that. What I would say is that the pollution is a problem. But I would say that don't look at the problem, but look at the solution. Now we have to see that there are two interesting episodes that have taken place. For example, when NASA began the launch of astronaut into space, they found that the pens they sent it with the astronaut will not work at the zero gravity. That ink was not flowing it. Then what happened? To solve this problem, it took the Americans 1 decade. They developed a pen that could work upside down, etc. And they spent about $1 million to develop a pen to write anywhere on any surface at any time at any environment, etc. $1 million. Because they looked at the problem and got the solution to that. Then, and what did the Russians do? They sent a pencil to the astronaut which could solve the problem. So the Americans looked at the problems and the Russians looked at the solution. And therefore, I would request you always look at the solution, don't look at the problem. Find the easiest solution into that. Then there is another interesting episode. So all these things, the pollution is a problem. Don't look at the problem. How to get the simplest solution is what we have to do. The other one is that one of the most memorable case studies on the Japanese management was the empty soap box, which happened in one of the Japan's cosmetic companies. The company received a complaint that the consumer bought a soap box that was empty. Immediately, he made a big complaint to the company, and then the authorities thought that this should not happen, and they have wanted to find a solution into that. They asked their engineers to do it, and then post-haste the engineers worked hard to devise an X-ray machine with a resolution of monitors manned by 2%, watch all the soap boxes that pass through the line make sure that they were not empty, and they spent about $1 million to solve this problem. Then what happened? Then when the work and file employee in a small company was posted, saying he said all these are nonsense, you should not use X-rays, etc. Switch on the fan, and the empty boxes that was the fan, they simply blow it out. So you have only 1,600 rupees is what is happening. And therefore, what I would always look at for a simple solution and devise the simplest possible solution. Always focus on the solution and not on the problem. Take each challenge, not with why you cannot do that. You should see that how to do it. So somehow. And whether hard work is important, whether knowledge is important, whether money is important, love is important, or the luck is important. And I'm asking the question, which is the most important thing is in life. And I would put it that not all these things are important. These are all important. In my opinion, attitude, discipline are the most important things in one's life, because that is what is make a person's life full. And therefore, have a positive attitude and have a good discipline, and you will make your life very successful. So thank you very much for that. If you have any questions, you may send the question to me, and I will try to answer that.
Chitra ma'am, I think there are 7 questions I'm able to see.
Yeah, yes, sir. There are questions posted for you. One of the questions is, what are the problems with 6-stroke engine and why it is not used in vehicles?
What is the problem of 2-stroke engine?
One of the question is, what are the problems with 6-stroke engines and why it is not used in vehicles?
Why 2-stroke engines are not used in vehicles? Am I right?
Yes. Yes. 6-stroke engines are why are they not used in vehicles? What is the problem there?
Yeah, what is the problem? Now, engines originally, when was invented, they have the 4 strokes, namely suction, compression, expansion, and the exhaust. These 4 strokes are that is being involved, and out of these 4 strokes, only 2 strokes were the most important thing, namely the combustion and the expansion. Combustion and the expansion, where the power is coming, that is suction. Compression, combustion, and expansion are the 3 processes most important. But the suction and the exhaust are 2 wasteful processes where we have to give power for the suction, we have to give power for exhausting the products of combustion. These 2, namely the suction and the exhaust, if we can get away with that, probably people thought we will be able to work with a 2-stroke engine. And the 2-stroke engine came, that is the entire cycle. The cycle consisting of suction, compression, expansion, and the exhaust, which is done in 2 cycles, 2 revolutions of the crankshaft. If it could be completed in 1 revolution of the crankshaft, then it could work on 2-stroke engines and the 2-stroke cycle. And there was an invention of the 2-stroke cycle, and there came that these 2-stroke cycles were most suited for either a very small engines, for example, moped, 50cc engines, or to a very large engine like ships, the megawatts. So the mopeds are in types of 1 kilowatt, 5 kilowatt motor engines, or the big engines in for the ships. That is where the 2-stroke engine could be used. In the other sector, if you are trying to use the 2-stroke engine it has got more pollution and its efficiency is much less because of the fact some of the fuel that is getting into the cylinder getting wasted, fuel is getting wasted out of that, and therefore two-stroke engine is more polluting than the four-stroke engine, and that is why it did not come for the SUVs. It came only for the motorcycles or when for the ships. Where in the case of ships they were using two-stroke diesel engine, and in the case of mopeds and the two-wheelers they were using four-stroke engine because of the problem of the more pollution from this engine, and these engines cannot be used for our automobiles, namely SUVs. So the person who has asked the question is satisfied with the answer, or if you have more questions, please ask him to ask.
Yes, sir. There are a number of other questions also, if you allow me.
Yes.
There is a question that in modern engine fuel injection system and spark plug, both are used, then how to differentiate them?
Your voice was breaking. I am not able to.
Yes, in modern engines, fuel injection system and spark plug, both are used, then how to differentiate them?
Fuel injection and
Spark plug, both are used, then how do we differentiate them? How can we differentiate them?
I'm not fuel injection and carburetor.
The spark plug. Spark plug.
Spark plug.
Fuel injection system and the spark plug, both are used. Then how to differentiate between them?
Professor Ganeshan, at the lowest strip on the screen, you will find a Q&A section is there. So even you can also access the questions.
Where? Q&A.
Q&A, right, sir?
Yes. Yes. What are the problems with this six-stroke engine? Why is it not six-stroke? Is it the two-stroke engine?
You have answered.
No, if you want to talk about the six-stroke engine, I am able to see the questions now. That will be easy for me to answer. Now we will come back to that. What are the problems with the six-stroke engine? Why it is not used in vehicles? Yeah, but I was explaining only two-stroke engines. Now, in more number of strokes, you have more problems. Now, what exactly the problem? Now we had originally four-stroke engine and two-stroke engine. The main problem with this engine is that we are reciprocating to rotate. What an automobile wheels want is a rotary motion. And this rotary motion on the wheel is obtained by means of the reciprocating action of the piston using the connecting rod and the crankshaft and getting the rotary motion. And the main problem with this engine four-stroke is a lot of energy is wasted in the friction. Lot of energy is wasted in the friction, and compared to the four-stroke engine, two-stroke engine has less friction because you are able to complete your entire cycle in two revolutions of the one revolution of the piston itself, crankshaft itself, whereas you required two revolutions in the case of a four-stroke engine. Now you are going to make it in the six-stroke engine, it will be still worse. That it will be getting into more problem on the friction. Further, one thing that we can do is you can do the available energy can be supercharged and can be used it. And if you make more and more strokes on the engine, you will be using more and more power, and therefore they are not used in the engine. That is the question for the first this one. And in modern engines, fuel injection system and spark plug both are used. Then how to differentiate? I don't know what is how to differentiate means. Suppose if you have gone through the spark ignition engine, originally we were using the carburetor, and the carburetor air fuel mixture is sucked and it is compressed and then ignited by the spark. So what is the thing is, if for the proper combustion to take place, if the proper combustion has to take place, the fuel and air should be mixed, and this air fuel mixture should be in the ratio of around 15:1, 14 to 15:1. Whatever way that you are able to achieve that air fuel mixture of 15:1, that will be better. Today what we are doing is that fuel injection, gasoline direct injection that is taking place. How this injection is taking place is not at the end of the compression stroke, but the fuel is injected in the suction stroke itself. And when it is injected, it is able to evaporate much faster, and the piston and the cylinder configurations are changed in such a way that they are homogeneously mixed. The idea of injection is to achieve a homogeneous mixing of fuel and air. And if you see the carburetor, we were not able to get exactly 15:1 for all the cylinders. Some engines, some cylinders were getting 14:1, some used to get a lean mixture 17:1, something goes to 13. So there is a small distribution of fuel air mixture in the cylinders. That was the problem with the carburetor. Now this small distribution is avoided by the fuel injection, by which we are able to get each cylinder exactly an air fuel ratio of 14:1, and the petrol engine being a low compression ratio engine, which is a maximum compression ratio today is 12 only, and it cannot ignite by itself, and therefore we require a spark plug to ignite the fuel air mixture. The idea of diesel is that use a higher compression ratio so that make the fuel to ignite by itself. But in the case of a spark ignition engine, your compression ratio is only 12:1, and therefore you definitely require a spark plug for the ignition. The injection is used to get a homogeneous mixture, and the spark plug is used to ignite the fuel air mixture. Hope I answered the question. And therefore, modern engine, fuel injection and the spark plugs are both used in this gasoline direct injection itself. Dr. Vinod Kumar, and good afternoon to all. Thanks for calling the question of IC, pioneer of IC engine. It is the privilege to. My question is, sir, how constant pressure is ensured in diesel engine as expected in diesel engine? Constant. So, if I understand the question, what he is asking is that how do we say that the combustion is at constant pressure in the case of a diesel engine? Hopefully, I think that is the question he is asking. How constant pressure is ensured in diesel engine as expected in a diesel cycle? Now here you have to understand is that there are two things. One is an actual cycle, another one is an ideal cycle. When we talk about to our boys on ideal cycle, we say that the fuel air emission, the combustion is taking place at constant pressure in a diesel engine. Now, why do we say that? Now, what you have to understand at this point is because of the injection and because of the combustion that is taking place, the pressure will rise. Because of the combustion that is taking place, the pressure will rise. But at the same time, you will notice that the piston is coming down. During the expansion process, the piston is coming down, and therefore there is a pressure rise due to combustion. There is a pressure drop due to the expansion of the piston motion, and these two things, the rate of increase of pressure due to combustion is equalized by the rate of pressure drop during the expansion, and therefore we say that the combustion is taking place at constant pressure in a diesel engine. At the same time, you also should understand that we talk to the boys that the constant volume combustion is taking place in the case of a petrol engine. But constant volume or constant pressure cannot happen in an actual engine. It is a dual combustion. Whether it's a petrol engine or a diesel engine, is a certain part is constant volume and certain part is a constant pressure. Sorry. And therefore, you will find that there is a pressure rise that will take place due to due to a constant volume combustion as well as the constant pressure combustion. And in an actual engine, there is no constant volume, no constant pressure. It is both constant volume as the constant pressure. That is what is taking place in an actual engine, whether it is petrol or diesel. I do not have that PV diagram right now to show it to you. If you send your email ID, I will send you the picture and explain to you more detail. And second question is, to meet BS6 norms, what modifications are required to be done in IC engines? See, the BS6 norms, whatever the norms is, that is year by year, government is putting more and more stringent norms to reduce the NOx and reduce the carbon monoxide, etc., etc. And all these things are achieved. Now, if you see that one way of this is making the homogeneously charged compression ignition engine, where you will reduce the NOx as well as they improve the efficiency of the engine. So in order to build that, a lot of work is going on in SCCA engine, but the cost is going up, and therefore these are all things are achieved. We are now trying to achieve it by means of better combustion, utilizing higher pressure of injection, and also better air movement into that. Hope I have answered, Dr. Vinod. Any questions? Any other question? Yeah. Sir, why pollution is not a problem in earlier days, while IC engine, why pollution was not a problem in earlier days, while IC engines came in existence? Now, what exactly is the pollution? Now, pollution today, what we are seeing is a gaseous pollution. Those days, what we were using, where we are not using the automobiles, we were not facing the gaseous pollution problem. The gaseous pollutants are carbon monoxide, carbon dioxide, etc., etc. NOx, all those things are coming in because we were not using petrol or diesel. That is the reason why we did not have pollution problem of this type, namely the gaseous pollution. But in those days, we had a solid and liquid pollution from the horses, and therefore that was solid liquid. This is the gaseous pollution. Engines burn the fuel air mixture into the fuel air mixture, which is a hydrocarbon and polluting the atmosphere. So, in my opinion, the best fuel for engine is hydrogen. The best fuel for the engine is hydrogen, and hydrogen, if you can tame it, if you can burn it inside the cylinder, you will get only water vapor. And probably we may be able to solve the water problem of our country also, with so much of vehicles on the run, and we will be able to collect liters and liters of water from the tailpipe, and we may solve our water problem also if we can use hydrogen. Then the question is, why we are not using hydrogen as a fuel? Hydrogen is a highly reactive fuel. So the difference between hydrogen fuel and hydrocarbon fuel is the difference between a newly married wife and a seasoned housewife. Hydrogen is like a newly married wife, and we do not know how she will behave at the time. We are not understood her. Whereas the hydrocarbon is like your mother. You have hydrogen and carbon, and they know how it will behave, etc. And therefore, the problem today is that the fuel is mainly responsible for the pollution. And in those days, when we are not using the fuel, there were not problem of pollution in earlier days. Not only that, the number of vehicles on the road have increased so much that we are facing the situation today. Hope I answered Himanshu. Why we only focus on positive side? Now we should always focus on positive side. If you are always thinking negative, you will never be able to do that. That is, there is no problem that is not solvable. Every problem has a solution. You can solve. If you decide to do that, you can solve it. And if you look at the positive side of it. Now, if you say, oh, negative side, you know the negative side and say that this is the problem, this is the problem. Don't look at the problem, look at the solution. If you look at the solution, all the problems will. So that is what I said. Look positive. Always look positive. You will be able to solve them. Don't look negative. And don't say that I cannot do this or I cannot do that. Each one of us has got are in the same environment, and if you look positive, you will be able to solve all the problems. We should, and therefore, my decision is that is the attitude. The attitude is that if you say that I have an attitude, a positive attitude, then I will be able to. That is what I said. If you have a positive attitude and a good discipline, you will solve any of the problem. Now I projected it. The what are all the most important things in your life? I listed 6 of them, and go to your home or the home. If you are still in the home and you put that, like the knowledge, KNOWLEDGE, you put A for 1, B for 2, C for 2, and Z for 26. You add all those things. You will find attitude get 100 marks and discipline also get 100 marks. And the positive attitude and good discipline, and within focusing on the positive side of this one, you will definitely solve all the problem and never try to look at the negative side. There any engine which works on both petrol and diesel? Probably it is not. Petrol is for petrol and diesel is for diesel, because petrol engine work with an air fuel ratio of 15:1, whereas the diesel engine can work with an air fuel ratio of 80:1 also. Petrol engine has a compression ratio of 12, diesel engine has a compression ratio of 20. And therefore, there are a lot of difference, though they work on 4-stroke engine, they have the difference in their combustion process, and therefore you cannot use petrol in a diesel engine or a diesel in a petrol engine, and you cannot use both in the same engine into that. And we are now trying to solve it by means of a homogeneously charged compression ignition engine. For that, where you use petrol and try to ignite it by itself. A lot of research is going on, and you cannot interchange the fuel for this engine at the moment. And the question is, there is no engine now working with both petrol and diesel. As the emission norms are getting stringent, is it possible that diesel engine can be banned in coming years because of pure emissions and compared to petrol engines? Petrol engines, they are also producing pollutants and some type of pollutants, and the diesel engines also making the pollutants. For example, if you take petrol engines, if they produce unburned hydrocarbon, carbon monoxide, carbon dioxide, and nitric oxide. What the diesel engine does, additionally of all the things, it also produces the soot and the smoke also. And the diesel engine is much more efficient than the petrol engine, and therefore with the invention, with the improvement in the injection, by having the CRDA engines, we need not have to ban petrol diesel engine at all. We'll be able to make it work better and better, and we will be able to reduce the pollution. The main problem is that we have not understood the combustion. We have not understood the combustion process, and those who are listening to me, I please send me the thing that I said, which will catch fire first, diesel or the petrol. And if you can send me your answer in the chat, then I will tell you how what it is into that. And therefore we need not ban the diesel engines. The engine with that, all these things we will be able to overcome in the near future. Don't worry about that. And Vinod Kumar, as the world is transforming towards electric vehicles, IC engines need to be replaced. Yes, in such a scenario, what life of IC engines in the years is left now onwards? It's a good question. Because people are thinking that in the near future we are going to have electrical vehicles. Being an IC engines man, worked for 50 years on this. Please take it from me that IC engines will be there until 2100. Today, 2020, IC engines will be there until 2100. 80 years from now, we may think about it, because you cannot jointly change into the vehicle with that, because what will happen is, today if you take it, you want to replace all the vehicles using electricity, no fan, no light in your house will go on, because everything used for charging the batteries, and you will not be able to do that. It will evolve over a period of time, and therefore the electrical vehicles will come in a slow manner, and the pollution will be in a different state. How to get rid of these batteries? How to get rid of these batteries will be the main problem that we will face, and therefore maybe in another 50 years from now, the battery technology can improve, and people are working with nuclear batteries, and they say that they are now working on nuclear batteries. If you put that half-life period is about 100 years, put a battery, it will work for 100 years, and that will be wonderful. A lot of technology is improving into that, and the automobile engineering as of now is a mechanical engineering subject, and it will go to the electrical engineering in the near future. Near future means 50 years from now, it may be an electrical engineering subject. So slowly the ICT will get out of the scenario, not now, maybe by 2100. Is carburetor there in a GDA engine? There is no carburetor in GDA engine. The carburetor is replaced by the fuel injector into that. It is said that, next question, it is said that electric cars are the future of automobiles. What is your thoughts about this? Definitely electric cars are future in that. Maybe my grandson will use it. My son will still use only. My grandson will be using it. That is what I'm saying. 50 years from now or 60 years from now, we'll be able to make it into the electrical vehicle. But the electrical vehicle has got future. We have to work on the batteries. We have to work on the batteries. And if we are able to make batteries for a long period of time, that will be wonderful. So I hope to some extent I have able to satisfy your questions by answering. And if you have any questions, you can send me. Otherwise, I can take over and tell me what to do. Yeah.
Please, vote of thanks.
Thank you, Professor, for making this talk very interesting. on combustion engines. Our student must have benefited from your discussion on CREI engine, gasoline direct injection engine, HCCI engine, which combines the advantages of both petrol and diesel engine, homogeneous charge compression engine, stratified Troncal engine. And thank you a lot for giving this mantra in life of attitude and discipline. We will try to keep ourselves on this and follow you, and we all have benefited a lot from your talk on
And,
this.
and I will end
Combustion.
my lecture with a story, that
Yes, sir.
attitude and
Sure.
story. Okay, this is the story. I would like to, but I don't know whether it's coming. It's not coming. I don't know. Okay, okay. The attitude and will to do. So you are able to see that
Yes,
screen?
sir. We are able to see. Yes, sir.
I'm not able to move the screen. I don't know why. No, I am not able to. Okay, and next time I will see. Okay, we will stop at that point. Okay, well, now it is coming. Please wait. Attitude and will to do. An old man.
Yes, sir, it has come. It has come, sir.
Are you able to see?
Yes, sir.
Yeah,
We are able to see the slides.
Yeah, I will end my lecture with this story. An old man lived alone in Minnesota, that is in US. He wanted to spare his potato garden, but was a very hard work. His only son, who would have helped him, was in prison. The old man wrote a letter to his son and mentioned his situation. Dear son, I'm feeling pretty bad because it looks like that I won't be able to plant my potato garden this time. I hate to miss doing the garden because your mother always loved planting on time. I'm just getting too old to be digging up the garden. If you were here, all my trouble would have been over. I know you would dig the plot for me if you are not in the prison. He wrote a letter to his son. Shortly, the old man received this telegram. For heaven's sake, Dad, don't dig the garden. That is where I have buried all the guns. Probably he thought maybe he is in the prison for that. At 4 a.m. next morning, a dozen FBI agents and local police officers show up and dug up the entire garden without finding any gun. And confused, the old man wrote another note to his son telling him what happened and asked him what to do next. His son reply was, go ahead and plant the potato garden. That this is the best I could do for you from here. Therefore, my dear friends, no matter where you are in the world, if you decide to do something deep from your heart, you can definitely do that. It is the attitude that matters and not where you are. And
Right.
have a positive attitude and do the best. So all that matters is the attitude and the will to do. And hope all of you will have it. And I mean, I can go ahead and all those things. Okay, we'll leave it at that. Okay. And you have in your life, you must have three solves. One is dissolve, resolve, and solve. Dissolve your negative attitude, resolve to be always positive, and you can solve any problem with that. This one. Always do things right. This will graduate from me and astonish the rest. Mark Twain said. So, in order to achieve all these things, you require the grace of God. That I believe. And the question is, which God we will pray? The Hindu mythology, there are too many gods for that, one for wealth, one for education, etc. But I would strongly suggest that all of you to pray this God only. Why? I will tell you the reason and close my talk. It is nothing to do with religion, caste, or creed, anything like that. And all of you should pray only this God in this 21st century. And this is the God. This is Lord Ganesha. And because not because that I am having the Lord's name, It is because this is the only God who is having a mouse in his hand, and therefore without mouse you cannot do anything in the 21st century. And therefore you pray this God, you will get all the things that you want. Thank you.
Thank you, sir.
So, thank you, sir. Thank
Yes.
you for such a nice interactive talk
Yes.
on behalf of Center for Advanced Studies and this university. We definitely, after the end of this lockdown period, someday we'll invite you if you can spare some time at our center. So this is a very new center. Dr. Rabesh might have discussed with you a lot about this. So we are on the progressive path with the blessings of senior professors like you. So one day, definitely, we will request you to visit our center. Thank you so much, sir.
Thank
Thank
you.
you.
Thank you very much. And I hope most of you would have enjoyed the lecture, and some of you would have bored also, depending upon I do not know what is this one. And therefore, I will take, let this corona be over. I would like to visit your campus and see what is that.
Definitely,
God
sir.
willing, we will meet in person.
Sure, sir. Thank you so much. Thank you.
Thank you. Thank you.
Okay.
Thank you for
Thank you,
that.
sir. Bye. Bye.
Thank you very much. I will stop share and